building we're talking about today is he said, Anthony, Edith Green-Wendell Wyatt. It's a 500,000 square foot building built in 1975 in Portland, Oregon. Architects redesigning, Jim Cutler, Cutler Anderson, and Sarah Architects. Give you a little bit of background. GSA has 1,500 owned buildings. This chart here, you can see about a third of those, 34%, are in the modern era, which is what this building falls into. That's 549 buildings of this building type. And where that's significant for us is the majority of the historic buildings have already been modernized. The new buildings don't need modernized quite yet. This is the bulk of our work for the next few years. We also have, there's an executive order on freeze the footprint, where we're looking to consolidate and do better utilization of the buildings that we already have. These buildings also are some of the worst energy performers. In the 60s and 70s, energy wasn't always the main criteria in building a building. As I said, there's 549 of them. There's one in every city in the United States. There are these buildings everyone hates. You know, Albuquerque, you name it. If wherever you're from, there's probably one of these federal buildings in your city. That said, some of the buildings, like the Chicago Federal Center here by Mies van der Rohe, outstanding building. This building, about 10 years ago, we had a symposium at Yale where we looked at the modern era buildings and looked particularly at those buildings that are preserve worthy, and we have a protocol that we go through to determine if, when they're 50 years old, if they're going to be eligible to be on the National Register. Some are already on the National Register. And those we handle differently, but Edith Green, one of those buildings that could have been anywhere, was ready for a major intervention. A little bit of housekeeping, executive orders that we operate on since 2007. We've had an executive order to reduce the energy consumption by 3% a year. In 2015, we're supposed to have the energy consumption reduced by 30%. We're at about 29%, so we think we're going to make it. It was a cold winter last winter, so we have our fingers crossed. And reducing metered water use by 16% as well by 2015. Then on ISA, Energy Independence and Security Act, if you go down the list from 2010, projects with a major modernization or new construction have fossil fuel reductions of 55% down to, when you see 2030, federal buildings, new federal buildings in 2030 are supposed to be net zero. So we have one net zero building in the inventory, but by 2030, all our projects will be net zero, which is important for us. We've got a lot to learn, and we're using projects like this at Edith Green to learn and move forward. We've had LEED certification as a requirement since 1999, LEED Gold since 2009. Edith Green was LEED Platinum. Our repair and alterations need $4.7 billion. There's, as I said, there's these in every city, every state. We do about $500 million worth of major modernization a year, so I've got job security. People like, there's a few people from GSA here. They've got job security for the next few years. Particular, this era of building is going to be big part of our workload. I like this graphic. It's one the National Trust for Historic Preservation used to talk about the most sustainable thing is to reuse an existing building. Part of this campaign, they had this factoid that building a 50,000 square foot building requires the same amount of energy needed to drive a car 20,000 miles a year for 730 years. 50,000, that's not that big of a building. If you consider a building like Edith Green, that's 500,000 square feet, that's driving 10 cars 20,000 miles a year for 730 years. Then taking that to the overall inventory of mid-century buildings, that's 1,200 cars, 20,000 miles a year for 730 years. It's an enormous amount of energy in the existing inventory. This is the building after the existing exterior was removed before the new elevations were put back on the building. I showed this. I think this is important. If you see, I didn't mean to do that. This area right here, part of this project, one of the things it did is it moved out from the geometry of the original building. It moved the curtain wall out. John will talk a little bit more about that, but what that did for this building, the way GSA operates is that we charge market-based rent to our tenants, so they pay market-based rent. In this building, moving that the curtain wall out added 21,000 square feet to the overall building. The mechanical space that wasn't needed added additional space, so that total there was the equivalent of one additional floor was added to this building. The way the Federal Buildings Fund works is the money that comes in from rent, we subtract out utility costs, overhead, et cetera, and what we're left with is the money that we reinvest in new buildings and major modernizations every year. So making a building energy efficient is important to the inventory as well as the amount of square footage. It's very similar as a commercial developer would work. Next, location, location, location. This shows the owned buildings, and actually there's a lease building in the Portland area that's more or less in the suburbs over here. And the point making here is that commuting back and forth can use 30 to 137% more energy than the building takes to operate. All of these buildings, mid-century buildings, they're in terrific locations. So 42% of existing GSA spaces within a quarter mile of rail transit. When you look at it and compare the greenhouse gas impact of Edith Green here versus one in the suburbs, suburbs versus downtown. Also the walk score, Edith Green, perfect walk score of 100. As opposed to 53 for a suburban office park. And you sort of think, often we have tenants who would prefer to be in the suburbs rather than being in downtown because it's more difficult. But if you look at this chart, this shows you that a 45-minute commute to downtown Portland to this site, what that map looks like and how much larger it is. If you're in a suburban location, that's a 45-minute commute on this side. Again, walk score, transit score, location, location, location. There's no reason not to reuse these buildings. They're most likely in the best location already. And then this map just shows you the proximity of the building and Portland's existing light rail system, streetcar, buses from here that it's already ideally located. Average walk score for LEED certified projects is 64. Again, Edith, Green-Wendell, Wyatt, one perfect 100. Just talk a little bit about the Design Excellence Program. Program was started in 1994, so we're 20 years into the program. Couple of big ideas. One is focus on the lead designer to get design talent, the best design talent to be the leadership on the program or on the project. What's particularly noteworthy about that is that you don't have to have designed a courthouse before to do a courthouse. We look for someone who's done a similar level of complexity and similar size project, but not the same project. So focus on the lead designer to get the right team. And we've expanded that to deliver an integrated project. And then second is peer review. We have over 500 peer professionals that are leaders in the industry, architects, engineers, landscape architects, security consultants, who we bring in on every project. We have, actually on this project, Don Stasny from Portland sat in on the selection panel, so he was involved from day one on the selection all the way through. We brought in other peers, Cecil Stewart, Sustainability Leadership Institute from Omaha, Margaret McCurry, Here in Chicago, Michael Willis, San Francisco, Calvin Lewis. We try to have a balance of academicians and private practitioners, people who have done similar projects. And also the peers, generally, they're kind of pulling, they're trying to get the best out of the designer to push them a little further. I would say in this case, the peers' role was more to convince GSA that what Jim was proposing wasn't too far out there and that we were the ones needing to be brought along. Small business initiatives exceeded all the small business initiatives. This was a recovery project, American Recovery Act project, created 1,500 job years in Portland, Oregon. This is the builder's plaque. Every building we do has all the builders who were the plasterers, pipe fitters, painters that were involved in the project. There are about 1,100 names on the front door of the project. That's everybody who worked on this project, majority of them being from Portland, Oregon. As well as using small business for local landscaping. Talked also about the apprentice program. In this project, the way they contracted the painting is that they had the subcontracts done by floor so that small business could bond each floor, and they would give a small business one floor. They've successfully completed that. They do the next floor, so that we get more local people and small business involved in the projects. And last, Edith Green-Wendell Wyatt's one of only 2 high-rise projects in the U.S. to achieve a LEED NC 2000 Platinum rating, and we're really proud of that. Jim?
First, this is a bit intimidating. I have to tell you that I am really honored to get this first award and to be in the company of such distinguished competitors. So that said, Wes has already explained that we had a 500,000 square foot building that was to act as a prototype for development for the inventory of the US government, which is for this era of building 60 million square feet. It was a bit of a daunting task. And I have to say that as lead designer, I was a very small piece of this. I'm really here representing a very large team of people. I was just ultimately hired to synthesize the information that a lot of people generated and try to turn it into something pretty, but that at the same time did the job. So that said, I'm going to quickly tell the story of the building here. Almost 10 years ago, Sarah Architects, which is a larger firm in Portland, came to me and asked me to be lead designer to compete to do this project. And the project was essentially going to be a mechanical upgrade, a seismic upgrade, and a security upgrade to an existing federal office building. And when I was sent the drawings, I went through the sections and I realized that the way the building had been built, this is actually an old SOM building, Skidmore, Owings & Merrill building, they had lost about 2 square feet per every lineal foot of elevation by this concrete panel that inset back in off the steel frame. And that if we built a new curtain wall out here, we would pick up 21,000 square feet of net rentable, and which would, as you've heard from Les, that's meaningful for the way that GSA works. Secondarily, we would reduce the energy costs for the building by having a modern insulated curtain wall. And then finally, the seismic upgrade on the building, which was going to be horrendously expensive, became almost unnecessary because we took all the concrete off the building, thus reducing its inertial mass by about 35% and eliminating the need for a seismic upgrade. So when we went into the interview, instead of presenting a design or how cool we were, better designers, we walked in with a pro forma that tried to show everybody that there was really good math to make this a sustainable building. We got the project, And now I'll go into a bit of the process. Now first I have to tell you, I had never done a high-rise before. I'm one of those guys that they put faith in, and I can't thank GSA enough for having the faith in us to do our first high-rise. So that said, this is where the building is. And you can see that straight up and down is north. The grid of Portland is twisted about 20 degrees. And I tried to bring to bear all my experience and knowledge, which is about 20 years in practice. But more importantly, I'm the youngest living Kahn student. I studied with Lou Kahn, and there are things that I learned from him which are really primary. That is that you look at the nature of every circumstance. That is the circumstances in which we build architecture. That is the institution that we're going to house, the place that you're going to place it, the materials with which you're going to build it, and you try to reveal their natures by employing them in a way that it reflects all the circumstances of a building. In this case, when you look at the institution, which is essentially commerce, office buildings, you look at these buildings and they're driven very much by cooling. I noticed the person who spoke from Hong Kong, that about 85% of their energy load of their building was cooling. And it has struck me that when you look at the circumstance here, that north is different than south, and south is different from east and west is hotter, and north is cooler, and east is just warm, and south the sun's very high and doesn't throw as much energy into a building. So it struck us that, this being my first high-rise, that maybe we shouldn't do all sides of the building the same. So that said, we started thinking of a building that would be different on every face. These are the first sketches. And frankly, we were thinking about a strange building, a building that was like a cyborg building. Cyborg in that it would have living walls on it, and that we'd have planters hung from it, and that the planters would carry vegetation that would be deciduous, that just looking at the cycles of nature, that in the summer, the western face of the building, which is the big heat gainer, would be completely shaded. These diagonal lines, because we're twisted on the grid, we could still leave views out for the windows. In the winter, the leaves would drop off and we get some solar gain in the building, which is pretty natural. Trees have been doing it for a long time. And we took this fairly far along to the point where we got full approval from GSA and the peers. And this was the design, and we were very excited about it. And then we hit a snag. This essentially failed. It failed not because it didn't pencil in the long run in terms of the energy configurations, but it failed because it had to wait for the plants to grow. And it would be unreasonable to have a building at this expense, it was $131 million, that didn't work day one. So that was the first failure. The second was that it made it to John McCain's list of the 10 worst boondoggles of the American Recovery Act. I was only second. I had wanted to be first, but we ended up second. We were beat out by a shopping mall in Texas. But those two events led us to have to redesign the building. And one was a fact and the other was an event. So that brought us to redesign. And we got together with Benson Engineering. They do curtain walls. Matter of fact, that the World Trade Center, the Freedom Tower, the curtain wall was being built at the same time as our building. In any case, after some real struggle, we developed what we called series of aluminum reeds that would be able to carry plants, but only from the ground up, but at the same time provide the appropriate amount of shading, the appropriate amount of reflection for daylighting, and that each surface of the building would have a different application for these. So there's the building. This is the original. This is there's the completed building. Here the building was eating $1.26 per square foot. Now it's at 18 cents a square foot, including the PV array on the roof. As you can see, west side, south side, different set of shades and vertical blinds and shades, plants growing up it. Again, the shading coefficients of the west side of the building. The reflectors, bouncing light in and also cutting off the more vertical southern light, and a different set of reflectors and vertical shades on the south side of the building, again with plants. The north side of the building didn't get any light, so it didn't get any armatures hanging off of it. The roof, however, besides being a PV array, collects rainwater, and we manage energy, our water savings of about 1.2 million gallons a year. The net result of all this stuff was that we were saving about 6,700 tons of carbon dioxide on this building alone, equal to about 40,000 barrels of oil. And if you spread this across the inventory of the whole federal inventory, you would end up someplace in the range of 140,000 tons of carbon dioxide saved, or at least not created. Now I've just got pictures of the building. Now, remember, this is a remodel. So we took, and those guys that built it, whether it was a good building or not, they had some history. The building had some history, and we felt that that history should be told, that we should honor the people who built the building that came before us, and what's more, we thought that it would create more pathos for the sense of time with this building. So we stripped the columns, we painted them with intumescent paint. To make another floor fully usable, we cut through the slabs to open them up to daylight to make more rentable space. Got it. I'm going to run a little late. These are the cuts. Which we think even the defects make it more beautiful and give us a better sense of time and history. Looking west. So I think I'm going to make this on time. What we did is we did achieve all the goals the government asked of us. We've set a precedent for another close to 60 million square feet of office space that needs to be fixed. And from our standpoint, what we've done is we've also created a symbol for the people, the citizens of Portland, that points out that their government supports them in creating a sustainable future. Our government buildings are the symbols of who we are. So they should be the people that should be looking towards a sustainable future. They gave me that charge, and we were, I hope, able to provide it. Finally, I know this is barely a high-rise building. It's only 18 stories. And it's not the tallest building in the world. And maybe it's cool, but it's not necessarily the coolest, slickest design. But on the other hand, most of the high-rise buildings built in this world are in the 18 to 20 to 25 stories. And the fact is that we wanted to create an example for our profession how we could create a sustainable future. And in that way, we felt this building looms much taller than the tallest of buildings. Thank you.